So reject this one. Let's continue with this because this is positive and this is positive. All right. So we have rejected this. Hello friends, welcome back again to my channel. In our lesson today, we are looking at this nice Olympiad exponential question. Let's see how we simplify this. So the first thing I want to do is to divide the both sides by the right hand side. I'll divide here by 4 raised to the power x, divide here by 4 raised to the power of x, then divide here by 4 to the power of x. So the next thing we want to do is, when we divide here, we'll have 1. We have 1. Then for this, let's apply the law of common powers, common index. We are going to be having 9 over 4 all raised to the power of x, since their powers are same, minus the same thing happens here. We have 6 over 4 all raised to the power of x. Now let's write this as 3 raised to the power of 2 over 2 raised to the power of 2. The index of 4 is 2 power 2. The index form of 9 is 3 power 2. Remember that all is raised to the power of x, minus here 2 can divide 6 and 4. So 2 divide 6, 3. 2 divide here, 2. So we have 3 over 2 all raised to the power of x equals 1. Now what else do we do? The power here, they are common. Power 2, power 2. So we can write the common power again. 3 over 2 all raised to power 2 all raised to power x, the x outside here, minus 3 over 2 raised to the power of x equals 1. Now, you know that when you have 2 times x, it is same as x times 2, right? So we can bring this s in and take this 2 outside. So I have 3 over 2 all raised to power x all raised to power 2 minus 3 over 2 all raised to the power of x equals 1. Now the reason why I had to do that is so that this and this will look identical. Then we can now substitute and simplify. Now since we have this guy and this guy to be identical, we can now choose a variable to substitute for the both of them. So we can say let p be equals 3 over 2 raised to the power of x. So anywhere you have 3 over 2 power x, we put p there. So we are going to be having p squared because of this square, minus here we have p equals 1. Now this is a quadratic equation, so let's bring this one to the left hand side. So we are going to be having p squared minus p minus 1 equals 0. So let's simplify the quadratic equation. Now this quadratic equation cannot be factorized because we can't produce a factor for -1 and -1. So let's use completing square method to simplify it. So to use complete square method, take this one to the right hand side. So we have p squared minus p equals -1, no, positive 1. Then find the coefficient of p here, which is -1. The half of it, 1 over 2. Then square it. If I square it, we'll have 1 over 4. Now this is the half squared of the coefficient of p. Now add it to the two sides of the equation. We have p squared minus p plus 1 over 4 equals 1 plus 1 over 4. Remember, we are looking for the value of p. When we have gotten the value of p, we can put it back in this expression and get the value of x, because x is what we are looking for. Please, if at this point you've not subscribed, please click the subscription button and subscribe for interesting math tutorials. All right, so what next? This is a perfect square expression because this is a square number, this is a square number. So to factorize it, just open a bracket, write p minus the square root of 1 over 4 is 1 over 2. I had to use minus because I have minus here. If here is plus, then I'll use plus here. You now square it outside. So we have factorized the left hand side. Then simplify the right hand side. 4 times 1 is 4 plus 1 over 4. Then add here, this is p minus 1 over 2 squared equals 5 over 4. Now to eliminate the power, take the square root of the both sides. So we have p minus 1 over 2 squared. Take the square root equals the square root plus or minus 5 over 4. Whenever you are solving quadratic equation and you are taking square root of the right hand side or the left hand side depending, you put plus or minus. So the square root cancels the square. We now have p minus 1 over 2 to be equal to plus or minus the square root of 5 over 2. I've taken the square root of 4, which is 2, but 5 does not have a square root, so I'll write it as a square root number. All right, so what next? Take this negative 2, 1 over 2, to the right hand side. We have p equals 1 over 2 plus or minus square root of 5 over 2. We've just taken this to the right hand side. What next? This is a common denominator. If you have common denominator, you add their numerators. So p will be equal to 1 plus or minus the square root of 5 all over 2, because they are common denominators. So we've gotten the value of p as this, but this is meant to be 2 factors, right? So we can separate it as p is equal to 1 plus square root of 5 over 2, or 1 minus the square root of 5 over 2. Because we have plus and minus, I split it into this and this. So at this point, we are going to recall that, where is it? We said let p be this. So anywhere you have p, you put this expression. So we record that p is equal to 3 over 2 raised to the power of x. So that means we are going to be having 3 over 2 equals, 2 over 2 raised to the power x equals this one, 1 plus square root of 5 over 2. We are solving it 2 times because we have this or this. So we are now saying again, 3 over 2 raised to the power of x is equal to this guy. This is all common. 1 minus square root of 5 over 2. Now, looking at the left hand side or the right hand side there, you can quickly tell that this is a negative number. It's a negative number because square root of 5 is bigger than 1. So when you subtract square root of 5 from 1, you have a number that is a negative. So the left hand side and the right hand side here are not equal. This number is a number way bigger than 0. So it cannot be equal. So reject this one. Let's continue with this because this is positive and this is positive. All right. So we have rejected this. We continue with this. Now to simplify here, we are going to be taking the logarithm of the both sides, right? Because indices cannot simplify it for us. We use the inverse of indices to simplify this. So what is the logarithm of the both sides? We are going to be saying logarithm of 3 over 2 raised to the power of x, this term here, to the same base. Use this as the base, is equal to, take the logarithm of here also with the same base. So we have the logarithm of 1 plus square root of 5 over 2 to the base of 3 over 2. All right. So what next do we do? The logarithm and the base are same. So you cancel out. This is equal to 1. So take only the power. X is equal to logarithm of 1 plus the square root of 5 over 2 to the base of 3 over 2. Now at this point you can leave your answer like this because we've gotten the value of x, or use your calculator and point the value. But meanwhile, some calculators cannot point the base. So I'll show you how to simplify until you get expressions that calculator can simplify. So to solve it further, we have x to be equal to logarithm of 1 plus 5 square root of 5 over 2 over logarithm of 3 over 2. The law of change of base. When you have a logarithm like this, you can split it into 2 different logarithms dividing themselves using a natural logarithm of 10. That is, the base is equal to 10. So at this point, you can press in your calculator logarithm of 1 plus square root of 5 over 2. Whatever you have, you press the logarithm of 2 over 3. and divide it, you have the value of x. So we'll be leaving it like this as our answer. Thank you so much for watching. Please do well to like this video, share to your friends, follow for more interesting math tutorial. Meet you in my next upload. Bye.